Okay. Hello, hello, hello. I hope you all are audible. And now let me just start this. Hello. I hope you are able to hear me. Hello. Hello, hello, hello. Hello. Uh, I'm just chatting. Okay. I hope you are able to hear me. Okay, so we will begin in another, by 8:15. So we will start in another, 4 minutes. Thank you for us. We need your support for, likes, shares, and subscribes. Uh, because it requires a lot of, there is a lot of hard work been going on, to bring you quality content which is going to be educational yet having a quality itself. And that's what our agenda, so that we can help people have education with highest level of quality with minimum cost possible. Okay, so we will be starting this task executor session in another couple of 3 minutes. Till we will be having our multiple people joining in. So we have one person joined, that is Boris. Thanks for joining. And we need a lot of people joining us, so that that becomes quite helpful for our efforts, as well as we have a great amount of our people getting knowledge at the same time. So I hope that in another couple of 2 minutes we will be having my us, and that's going to be a great success for us. So hello guys, if you haven't shared this with your friends, please do share it with your friends and your colleagues, your teachers, so everybody gets the stuff into that, because really it's going to be a very difficult task for me to arrange this with all the stuff just for you. Okay, okay, that sounds great. So we have three peoples, joined us in order to join, move together into this live session. Great. So just 1 minute going on, and we will be moving into our Flexim window where we will be covering all about task executors. And the best thing which I feel about this live session is that you can ask me the questions and I can try answering those live right away. If not, then I can also put that in the chat later. But it becomes very interactive when we go live, and at least for education, I feel that going live is an excellent option because it's just like having a what I can say a classroom session together. Yes, and I hope these technologies and tools would have been taught in schools and colleges at my time, but currently now they have started teaching these in the colleges as well, and the in the universities as well. And yes, we have reached our time, that is 8:15, and here we start the session. Okay, so you see here we have the source being placed. Okay, source is from the category of the fixed resource. I'll just remove that. This is our flexible model environment. Okay, and if you could see what we have Amira. Hello, hi. What is the plan of this live? What we will see about task executors? Great. So let me, just talk about what we are going to have today and the task executors, right? So thanks. I'll just put that thanks. Thank you, Amira. Great. So to summarize what we're going to, learn in this today's session of task executors, we are going to learn differences in network nodes and AGV paths. Okay, we are going to learn about robot properties. Okay, then we are going to learn about AGV charging logics, allocations, deallocation, control point tricks, and the things you must remember while putting the control points onto the game. Then we are going to learn about, or we are going to see about operators, different types of travels, then operator sharing tasks. Okay, then operator animations. Okay, in short, probably if possible. Then AGV, tugger, and then the material transfers by the AGV. Forklift utilized for loading and unloading this task. We will be also looking in, if possible, some of the codes, what I can say, the Flexim scripts, and then how we are going to ask the operator to pick an exact item from a queue, some basic stuffs, traffic analysis, congestion check, and heat maps. Okay, I hope Amira I have answered your question, right? And now let's go ahead, beginning with the task executor. So I have already created in detail videos about everything, what is this task executor, the properties, capacities. You can look into the playlist. I have done that already for all the elements available here, and the videos are still going on, and it's going to be coming. We are going to get new and new videos coming continuously on LeanSimCorp channel. Okay, so if you haven't watched this in detail, you can watch it in the playlist. So let us go to the more specific points, very important stuffs and related. Okay, so what we are going to do, so as I mentioned, what's the difference between the network nodes and the traffic, sorry, AGV? We are going to look into that first. So what I'm going to do is basically, let us create a small stuff. Okay, what I'm going to do is, great. Thank you, Amira. So just if there are any issues in the network, please let me know in the chat. Any issues in the sound, please let me know, because I would not be able to know what's going on there. So here is our keyword coming. Okay. So I'll just show you very interesting stuffs. Transferring the material from these two queues using our task executors. Okay, so what initially I'll just reset and run. Okay, So you're directly going to get the boxes, right? But if you want to have the boxes transferred by different type of entities, probably, okay, then you're going to use the task executors, right? So let us use operator first, okay, who is going to transfer the parts from the queue to this particular area, okay. So if I check this, use transport, he is basically going to transfer this material. Like I know this is, you already know about this, okay. So the operator goes. Now, if you see here, the difference is that the operator, the task executor goes with the shortest path possible, okay, the least distance. It will basically go diagonal if this was, or a straight path. So the least travel distance required would be followed by this particular operator, okay. Now I'll just delete this operator and let us bring in a robot, okay. Say this robot is going to use for transferring the material from one area to another. But now, what do you see here? The differences, right? That this robot is directly putting this thing from here and here, right? I don't know from where it is going. It might be going from the air, right? So that's not a good thing. Now, what you need to do is you need to use the six-axis robo. How? Is that you want this robo to not only pick this up from here, but also travel here and place that down, right? Okay, great. So that's what we are going to make now. So going into the network nodes, okay, I am just dragging out a network node here. Let me move this out, and I am just making this a pathway here, okay. And so these all are done by the A connection. If you don't know how to make this, you need to use A connection, where you are going to connect to this you know uh, node, and you also need to connect this queue to this node. The blue colors are for the objects which are going to be connected. Red color, it would be for the task executors, okay. So now we'll just reset this and we'll just run this, okay. So now what's happening, guys, right? He is now moving to the particular location. He is then picking that up, and then he is unloading to this. Guys, there must be claps and likes. Come on. Okay, great. Thank you. Uh, okay. So here is what we have. No, so this way the robot also can be used in order to transfer the material from one part to your another location, right? So you can use this a six-axis robo in this manner if you want to transfer the materials accordingly. This is okay. Now what we are going to do is, then I'll just remove this probably, okay, the robot. So in robot, you can see there are multiple stuffs in here. We already mentioned that in the video where we had robot put it into, but there are multiple triggers here as well, okay. Okay, so these triggers are very helpful if you want to do or perform specific things onto the object or onto the robot based on the triggers you had. Okay, let me see what's going on here. Amira says, in this step, can we use the emulated variables from the process flow to control it? Yes, definitely. So what you can also do is basically, you're talking about basically using emulation, yeah, right? You're going to talk about this variable right here, this one, and you're going to talk about this one, and then here probably, uh, okay, you're going to have this OPC UA, OPC DA. You can have an internal emulation setup, and then you're going to have two different types, which is going to be your sensor. Okay, this we don't use by the way in the emulation. We always use these variables. Here you just need to select, what type of, one second, where is the internal emulation connection. Here you can have this OPC say DA. So this is going to be your master stuff. And here when we talk about this, what I can say, then we are going to have OPCDA control tag, we are going to have OPCDA sensor tag. Okay, and here you need to write a event. Okay, so whenever you're going to get a detail from your server saying that you're going to have say 1, then your robot should start. If then it comes 2, then your robot should move. So what happens in emulation, you just need to fetch the value 1, 0, boolean, whatever you're going to get it from the PLC and the server. But the backend coding you need to do in that process flow or in that variable. You need to send the message, then from the message you need to control the start and stop. But yes, to answer your question, it is possible to basically what I can say, what you mentioned is in this step, can we use emulated? Yes, we can use emulated variables, but just to move the robot, to tell it, okay, you start moving now, okay, you stop now. So that things you can do here in this thing. Okay, great. So what I'm going to do now is let us delete this robot now. Okay, and what I wanted to say is that if I just put in this thing task executor and I just connect this is a forklift now. Okay, and when I just reset and run this probably, so now this is probably, I'll just move this here. Okay, and I'll just show you how it is moving. Okay, so this the task executor, if see, he is not following this path. Why? Because we didn't connect to that. Okay, so it will be going this way. That is the shortest distance I have mentioned. Okay, that is what he is going to follow. So you need to be very specific that you need to connect these both objects here and also the forklift to this area here, then only he is going to travel through that area. Okay, so he is going to use that particular path. Okay, this way it's going to be carrying out. Now say you're going to need multiple stuffs in there, like multiple parts together. This is also possible. It's just a matter of changing that capacity of that. Okay, now what we are going to do is I'll just create so similarly it is for crane. So crane doesn't require anything. Okay, then when we talk about this related to network node, I am just talking. Okay, so the important part I wanted to show you was that the robot, you can move from one place to another using the network node. It's very helpful. Okay, now what we are going to look into is we are going to check about the AGV now. Okay, let me just remove this and create a AGV network. Again, AGV is basically a different what I can say path structures out there, but the AGV comes under task executor, only the paths are different. Okay, so I am now creating this curved. Okay, I'm creating curved path here. Okay, here, and I am now putting in the control points out in there. Okay, here are my control points. Now we need to connect this control point with my objects there, and I am going to bring in my AGV, that is the task executor. Again in the task executor here. Okay, yes, you are going to have trucks, aeroplanes and all these same perform accordingly. Now what we are going to do is we are going to connect this AGV task executor there. Okay, travel location out there. Okay, and now what we are going to do is let us check whether my AGV is transferring the material for this AGV particular path. Okay, let me just run and show you. We are going to look at multiple interesting stuffs for this AGV, just so do not miss even a minute now. So I'm just running this. Okay, our task executor has started moving out. Okay, it will come at this control point, pick it up, and it will go to that area and it will unload this. Now if you click on this task executor, you see that the speed things are completely gone. Okay, so you cannot put in the speed stuff there. Thank you, Amira. Thanks a lot for your comment. Thank you. I'm just putting that there. Thanks and thank you. Okay, great. So now this task executor. The biggest thing which I was thinking about, why is this way? Like you cannot enter your speeds in the AGV here then how can I change the AGV speed? Okay, so the AGV speed now needs to be changed by right clicking on your AGV network and then coming to this area out in here. Now here comes your complete AGV network properties, which is very different from your network node stuff. Okay, network node stuff, it's just like a nodes placed out in there and you're just connecting those and it's moving. When we talk about AGV path, it's a complete, it's a bomb. It's like everything and that particular stuff. Okay, so if you look in here, we are going to have different stuffs in here now. Okay, you're going to have accelerations, you're going to have the speeds in here. You can modify those forward speeds, reverse speeds. You're going to have the battery usage here. You're going to have a rotation speeds as well here. Okay, now the units are going to be similar to what your model units are. Okay, so whatever your model units were, like if you go to the model settings, meter per seconds, it's meter per second square, it's meter per seconds, and batteries are in amperes. Okay, yes. So guys, I've also started the series on coding in Flexsim, started a series on industrial AI using NVIDIA. We will be soon bringing in the tutorials related to plant simulation, Technomatics Plant Sim. From next this coming Wednesday, you will be seeing Plant Sim as well, and you are going to have the Flexsim as well. So guys, do not forget to please hit a like, put in your comments, share with your friends, and subscribe to the channel, because at LeanSimCorp, we are going to try bring a complete domain and support related to engineering, automation, industrial AI, and digital transformations. So stay tuned. So when I am talking about this now, okay, let us do this thing. Okay, change the capacity of this AGV to 3, and I'm just resetting and running this. Okay. Yeah. What happened is, even though the capacity is 3, nothing is happening. Let's do this now. I'll change this interval to every 2 seconds. Okay, and then we are going to have multiple paths. I want to show you something interesting now. Okay, so the 3 parts are now coming on the top. What if I want to make it as a tagger? Okay, I want to make a tagger, but visualize it as tagger. Okay, not pure tagger. It will be looking like a tagger. Let's go in the AGV network properties. We are going to attach as a trailer, reset this, and we're going to run this. Yes, just look at this, guys. You're going to have this a train-like structure moving behind that, and that is going to be a particular thing like this. What you can also do is you can attach the empty cards to this AGV. Okay, Boris has something. So excellent explanation about Flexim. I'm following you from Bolivia. We have several people who are going to follow you. Thank you. Thank you very much, Boris. I really love you. Please share, with your contacts, multiple people, several peoples, and let us make them part of our family, right? I really love you. Thank you. Thanks a lot. Thank you. Thanks a lot. Let me give you this great emoji. Okay, great. Thank you. So, okay, great. So we have this tuggers been made. Okay, so I was talking about that, you can have this empty card, and in that empty card, you can put in these boxes, and then these boxes will be transferred ahead. But this is the simplest way to analyze, how this tagger is going to be behaving. Now, when you go here, okay, you are going to have here battery, you are going to have here idle, you are going to have your recharge. So whatever rates you want to put, like one of the point mentioned was that AGV charging logics. So what you can do is you can check in here, that what is your idle rate of discharge. You can get it from the vendor, the details, and you can put it here, the recharge rate, the idle usage rate, and the capacity rate. These rates you can put it, and based on that, the AGVs are going to be discharged and charged. Okay, so what is going to happen now is basically whenever you can see that what's going to happen and stuff like that into the multiple stuffs in here. So I'm just closing this. Okay, and if you run this, you're going to have this. Now say for example you want to put in the AGV battery details onto it. Let us do that now. What we are going to do is, on load, whenever my AGV is going to get loaded, I am going to put a battery details onto my AGV. Okay, so here I go, I put in a label. Let me put a label of battery level. Okay, and yes, and let me copy this. Okay, now what I am going to suppose to be making is, okay, so let me put this as integer battery level. Basically I'll put it double because then I also need it like 99.25, 99.5, right? So here I'm putting like AGV dot, you're going to get this AGV is going to be your current AGV equal to current. Let me just close this. AGV dot, you're going to now have battery level. Okay, great. Okay, okay, this is task executor. Current let me change this in here because that task executor is already being taken care as current. Okay, so now what I'm going to do is I'm going to print in the label value of this from this, as the battery level here. So let me make this okay, and let me make this run, and let us check how much battery you are going to get onto the AGV from that, if we were to check that out. Oh, 1 second, what happened is, current dot battery level, here I put in current dot so here basically I'm just closing this and I'm just resetting this. AGV equal to TE dot okay. So let me check with the syntax and I'll just come back. I don't remember that now. 1 second, I'll just check that. Here comes the AGV syntax out, and here I open that. Okay, great. So now I just click on this, okay, and now what I do is double battery is equal to AGV dot, these properties is what we should get in. Okay, so let us look at this. What has been happened is AGV was defined as AGV, which is equal to again AGV as a current. Now if you see, I am now able to apply the properties. Now I am able to apply the properties of the AGV to this, so now we are going to get the battery level, guys. Okay, so here I put it here, and then what I'm going to do is current dot battery level is equal to the battery level. Okay, so we have got a value for as of a AGV's battery level, and then we have placed copy pasted it onto that. So you need to remember the syntax: AGV equal to AGV current, then only you're going to reference this AGV with its properties of the AGV. Okay, great. So now I'm just resetting this, and I'm running this. Okay, I'm just running this. No errors now. No, it's errorless. And here comes the battery level, that's 99.87. Okay, this is how you can check in the battery level of yourself. And whenever your battery level falls below something, you can put in the another logic to that particular thing and ask that to travel to that particular location and stuffs related to. Okay, so now let us come back and understand that what are the differences in the AGV network. What you can do? So you can attach the loads at the trailer, you can mention the gaps. Okay, you can put in your charging details here, which we just saw how it is visible. In the control points, you are going to have these different process flow details you are going to put in. Accumulation types, here you are going to put in a proximity detection, like when your AGV should stop, at what trailing edges, and details related to what should be the intersection stop points. So it is based on the modeling part. This is based on the proximity part. When you go to the deallocation stuffs are nothing but very important point. Okay, because on that it's what we are going to have different steps being taken care. So one thing I'll just show you, if your simulation model is not getting this detail. Okay, I'll just put in a control point and another AGV out in there. Okay, so we have two AGVs now, and let me put in a dispatcher to be connected here to this queue, and from this queue we are going to connect it to the AGV, and let me just remove the AGV connected there. Okay, now when I reset this and when I run this, what are you going to see? Okay, it's going to be very critical now. So what we are going to do is we are going to have this different paths out here. Okay, let me just put in here, and let me put in a control points. Where are the control points? Yeah, control points here. So 1 2 3 4 and 5, right? And then I am going to connect this here, and here I connect the curved path again to the yes. Okay, reset, and I run this. Oh, these control points were moved. Okay, reset and run. Okay, now my AGV goes. Now if I just look at this, here I go into the output. I have only task executor 2, no task executor 1. Task executor 1 has got connected to my first port, so my second AGV is not going. So let us connect that. Okay, and let us reset and run now. Okay, so now my two AGVs are moving, guys. Okay, you see this? Two AGVs are moving. Now what I want to show you is, if you see, how are they moving from the control point? Just look at that. Okay, so on the control point, when you click in, you see this deallocated at the next control point. So unless and until your AGV reaches the another control point, it is not going to leave that, and because of that, what's going to happen is your throughput is going to get reduced. Your AGVs are going to be having a lot of blockage. Okay, so what do you need to do? I'll just show you one example. Let us delete these control points now and just show you. Okay, and I can show you. Let us see if it is possible to have a state dashboard. I'll just stop that, reset. Okay, and let us put in these two task executors into the details. Okay, so I just want to show you the blocked one. Okay, so okay, what happens is, you see this is all blocked because this is what it says is that deallocate at the next control point. When you click on this, when pass, you will see that the blockage are going to be minimum. So always try to have this, what is that, deallocate when passed. Now why it is still there? Because we need to change that to all of your control points. Deallocate when passed. I'll just delete this for now. D when passed and passed, and I'm just relating this. The moment A is going to leave from our that control point, we are going to have that moment coming backwards. So the blockage will completely go, and you will have a very least amount of blockage available out in there. Okay, so whenever you are using this AGV path, you need to remember that the control point needs to be deallocated when passed. So you have minimum blockages onto this route, helping you make this stuff quite great. Okay, so when we talk about the major difference between the network nodes and the AGV paths, both are going to be two-way, one-way, whatever that is. You're going to put in a speed limit for the network node, but here you are going to set up a complete speed for that particular AGV network. Okay, there is nothing like you are going to set it up like for this path different, this path different, this path different. No. Okay, you can have different types of AGV types. Okay, AGV type path you can basically select, and that you need to select from here, AGV type. Okay, which we just created, right? AGV type 2. If you want to have AGV type 2, use that, but again, that is for the particular speeds which we just made for that. Okay, but you cannot have different types of speeds at these different sections in this AGV network. But here you are having option in the network node which you can place that. Okay, so when you click on this, you see here speed limits are there. The maximum speed that a traveler can travel along these connections in meter per second. Okay, the disadvantage of the network node is that you cannot put in your curved speed, you cannot put the charging details, you cannot put your trailers and things like that you can do in the AGV network. So you can use AGVs on this network node as well and on this AGV as well. Let me know in the comment section whether you want to see that AGV to be ran on the network node. If not, I will skip this and go ahead. Okay, what is Boris saying? Excellent. We are going to write you inbox a strong hug from Bolivia. Thank you. Thanks a lot, Boris. Lots of love from me as well. Thank you. Love you. Okay, great. So here, we were talking about these two major differences. Now let us try making a heat map. Okay, and that is going to be a great stuff. Anything else? Risk vending, operator pick up exact item. Okay, great. So now what we are going to do? Let us use AGV heat map. Okay, so heat maps you can do also onto the network nodes. So basically, if you want to create a heat map when your AGVs are running onto your network nodes, that is also possible. You can do that, but that will take a lot of time. It requires backend coding and scripting. Okay, we'll do that later. But yes, just for your information, let me know in the comment section if you want that. Okay, great. Let us have this model standing here, and what we are going to do now is let us create another source and another queue. Okay, and let me just connect this to this queue. And what we're going to do is basically we're going to send the parts to these different types of queues based on the percentage. Okay, so send to port, when you go, you need to go here, to have a by percentage ratio. So what do you need to tell us? 80% of the parts will go to my port 1, 20% will go to my port 2. Okay, let us do this. Let me make a operator here which is going to have a center connected, and let me bring in the AGV's preferred paths. Okay, when I just come in here, if you see the navigator, here you can have a default navigator, you can have a default network navigator, you can have a AGV network, and you can have a AGV A star. Okay, AGV A star, you see that it's connected to our AGV. Okay, so if I just put in a grid, here comes a grid. Okay, so here comes your AGV grid, here comes your preferred path. So these are all A star detailings, okay, which you can use in. So this preferred path is going to be your magnet, just like a preferred path. It is going to be a bridge, it's going to be a mandatory path, you are going to have a control. But the big thing is, on the spot, there's a lot of thing in the Flexsim which you need to remember, and the things need to come out their way. What I am just searching now is the A star navigation property window. Okay, here there, if you are using A star, you get this mandatory path, mandatory paths traveling out in here. You can check this if you want that AGV that operator to travel based on that. So I'm just running this now. Okay, let's see how it goes. Oh, I'm not getting anything from the source. So now what I'm going to do is I'm just going to show you a heat map, and let us see that. Wow, why am I not getting? Oh, probably that we haven't checked this. Okay, we checked it now, so now the operator must be utilized. Wow, now the operator is moving. So if you see something here, this is the preferred path I have placed. Okay, but if you see, I haven't connected that operator to that preferred path, but it still follows that. That's the power of A star navigation. Okay, If you had seen here in the network node, you need to connect that, right? Here, if you just select that, right, the AGV, A star navigation, and it's done. It's so great. So you need to not just connect again and there, okay? It will automatically get connected to the AGV, A star, whatever paths and detailings you have been placed into. Let me just put in a divider, because what I'm searching is now I want to have that A star which used to initially come in our older versions and stuff, where A star used to be visible. I'm not able to see that now. I want to see that, here in the A star navigator. Okay, great. A star navigator properties come in here in the tool. I am able to see that. Okay, I am able to see it here. So now these are the A star properties out in here. Okay, now all members are there, travel members are there, FR members are there. What we are going to do, we are going to put in, we are going to start the heat map. Okay, so here the heat map is going to be started in A star navigator properties. Okay, so guys, my throat is almost dry. Let me have a sip of water. Okay. Okay, great. So now let us check how the heat maps are going to be shown. Okay, heat map colors also you can edit, but as of now we'll not keep that. We'll not, do anything onto that. So I'm just running that. Now what do you see? The operator is putting it into this area as well, only in this areas, right? We need to make this grid bigger so you see everything. So let me reset and run this again. Now here, if you see, right, the heat maps, this way you need to activate your heat maps from your A star navigator. Okay, I am just moving this show allocations. You see the allocations. Now you can see the allocations. This is the allocation power. So if you want to see the allocations, you need to check this out in here. Okay, then when you uncheck this, you are going to have the allocations being shown as none. So what do you see here? You remember the percentage? We put it here 90% something, right? 80% and 20% here. You see this green is here and the red is here. Let us change and see what heat maps give, is going to give us if I make this complete opposite. 80% below and 20% on the top. And let us see what our heat maps look like. Okay. So what is happening, guys? It's not showing you red. Why? Still it's showing you yellow. Can you let me know the answer in the comment section? Why is this happening? Why it is in green? Still we like, if you remember, we put it 80% here, it was complete red. Here it's still green even though the percentage is 80%, right? What might be the reason? What might be the reason? The reason is heat map depends upon the interval you are going to select. Okay, the intervals which you are going to select, that intervals are going to be defining what's that. So when we go in the conditional or the triggers in the visuals, the maximum heat value, this is traversals per time, average blockage time per traversal, percentage of the total time block, percentage of the total traversals. Okay, so how many times the people are traveling through the particular area is what is going to determine that how much your heat map is going to be visualized. Okay, so traversals per time, 0.1 traversals per second. If you're going to have, you're going to get it lit. What if it is 0.5 traversals? Okay, what if it is 0.5? Very less. Very less we have made this. Now if I just make this faster, it's not going to be visible because the traversals we have increased for that particular time unit. 0.01. You're getting me? You're getting me? 0.5, sorry, 0.05. Okay, now you are somewhat realistically able to see what we did. Now, what was happening here? It was 1, then you were seeing everything green, right? Green. But the moment you made it 0.2, right? What was happening? You are able to see that redness here and the redness there as well. What if I make this 1? Okay, so it depends on what traversal value you are going to put in there, maximum heat value, okay, in order to get the heat maps. You can also change the details in here. Okay, this is really a good question, Boris. How could you graph the visual representation of a heat map? So basically, if you want to have a graph of, basically, if you want to have a dashboard, or you're going to have need a value, so both way it is possible. You can get these details, you know, in terms of nodes. Okay, so basically, when you go in this backend, you are going to have the details into the AGV network properties. Okay, and there you are supposed to collect the details. Okay, the heat map total traversals, you look this. So there are different things, means basically, there are a lot of details already fitted into this. You need to pull the details out from the tree. Okay, so that basically what you can also know is you can get a number directly and you can feed that into the global table stating that you are going to have these many traversals on this many traversals on this, or you need to. So the basic form, what you're going to get is you're going to get numbers. That numbers you can collect in the global table, or those numbers you can put into the dashboard. No, but again, the base would be the numbers. You will be getting the traversals, just like I showed you right now. The total traversals are 812. Okay, again, you're going to have this all. You see this total traversals 2, block type 0. You need to plot, you need to track this grid, you know, and then you're going to get it what you want. Okay, so this way you're supposed to going to get in what is the traversal. So you see there are some areas where traversals are 18, 33, 24, 25. So you are supposed to collect the data from this tree and then convert it into readable format. I hope I have answered your question. But if you are asking very specific that can you give me a model, or can we have a video on that, how to get that? Yes, I'll try my best to bring a video onto that where you will be able to get in a data for the heat map of your particular paths. That say I have two paths, and on my two paths, this path had how many traversals, this path has how many traversals. Let me know in the comment section if you want that video. Okay, great. Great, Boris. I hope I have answered your question. Okay, great. Thank you. Okay, great. So what we have covered as of. So difference between the nodes, AGV path, how to make robot to travel, the robot properties in the details. We have already covered that in our in detail video. Some of the great tricks I wanted to share with you, that is the AGV charging logics. Then allocations and the deallocations, right? I'll just reset this now. So this was allocation, deallocation, which I just told you. If you're going to get a lot of what I can say blockages, you have to go with this so that you get least blockage. Control point tricks, you know, when we talk about the control points, oh, one second. The control points are going to be, allocated based on the details. So this control point, this was the point which I wanted to tell you about. And the control points can only be used onto the AGV networks. Then what was the another point was that operator different types of travels. Okay, great. So we saw that the operator we used has been traveling from this preferred path automatically because he was connected to the AGV, A star network, right? Now, say I want to remove this from that particular AGV navigator. I want to use the default navigator. What he is going to use, let's see. Okay, see, this is the default navigator. Now, if I change this to default network navigator, you're going to get an error. Why? Because your operator is not connected to that. Even though if your operator is connected to that, your queue is not connected to that. That's where you're going to get that error. So what I'm talking about is different types of travels by operator which you can make in, and this is that I'm talking about. So we saw you can use a star so directly if you see, if I put in a star navigator, it is directly getting connected to a star. Okay, if I click in here to the no default network navigator, it is directly going to connect to that. If you are going to connect to AGV network, it is directly going to get connected to the AGV network out in there. But the problem for us is that our queue is not connected to the AGV network. Okay, so it is not that you're just going to use AGVs onto your AGV network. One second, let me just check, connect this. Okay, yeah. See, the operator can also travel from the AGV network. It's not that only AGVs can travel. And if you could see this, see, it is also behaving like a trailer. So in Flexsim, it's all depending upon your path networks you are going to use in. Here the operator is also functioning like a AGV. You see this? So it's not based on operator, it's based on the AGV network. Okay, great. So this is what we saw, the best part of the network, best part of the, what I can say, the routes that operators can also run on the AGVs. Now, we need to do nothing, right? We just selected the AGV network and the operator came here. If I put in a default network, again it will be disconnected from this, and my operator is free to deliver my parts irrespective of the paths he is going to have. Now, wow, look at this. My operator is walking in a reverse direction. Now, what we're going to do is we are going to check these four things. I hope you are aware. If you are not aware, you can have a glimpse of this in a minute. Okay. So when we say do not travel offset, these are details for this. Let us look in here for the AGV. Now, if you see AGVs, okay, AGVs, when I click in, I'll come back here. Yeah, use navigator for offset travel. If I put travel offset loads and unloads, let's see what happens. Let me make this grid inside, because of that I'm not able to see the AGV path properly. Okay, nothing happens. When I click on this, it's like travel do not travel offset, use navigator offset, travel offset for load and unloads. See what was happening? Did you see this? What's happening? So the AGV is now traveling outside from its area for loading and unloading. Okay. If you want to have that, you can use that. If you don't want that, change that to do not travel offset. It will not travel. Okay. And similarly, you can use do not travel offset block spaces on the network nodes and use navigator for the offset travel. So I hope you also know now that how you can select the AGV network. Okay, sorry, AGV path, AGV type basically. You need to click on the AGVs. Okay, I'll just reset this. You need to click on the AGVs and you need to select the AGV type you are going to follow. Now, if you want to change the direction of the AGV itself onto the AGV network, just click on this and you're going to have this AGV network. AGV's directions being changed. You see this? This is how it is going to work. So these are different stuffs you can do in. So I'll tell you some of the bonus trips also. Okay. Which can really help you apart from this task executors. Okay. Now we saw operator sharing. Okay. So now what we will do is, let us remove the output from this. Okay. And I'll just delete this. And going out here. Okay. Now what is going to happen is we are going to check how multiple operators can be used. So operator animations in short, AGV tugger done, forklift utilization for load and load done, how to ask operator to pick exact. Okay, so there are two things remaining, three things. One is operator sharing task, then operator picking up the exact items from the queue, and then operator animations. Okay, so we are going to have 5 to 10 minutes and then we will be closing our live session. Okay, great. So let us do this thing now first. Dispatcher here. Yeah, coming out here, dispatcher here. I just want to remove this now. Yes, and here, one here. Let me remove this. Okay, and a connection to the operator. Okay, great. We are going to have the another operator here now. Okay, yes. Let me delete this. I cannot delete that. I am just moving that. Okay, so we have two operators here. I am just moving this, changing the sources to okay, reset and run. Okay, we have this. Now in the comment section, you are going to tell me how I'm going to make these operators back to their working mode. Why they are walking in reverse? Why they are not walking? Why they are not turning back and coming back? Okay, you're going to let me know that in the comment section. That's going to be the assignment for you. Drop in your answer that why is this. I'll just show you the properties of the operators as well. You tell me that why these operators are not turning back. Okay, where is the answer? Okay, so I'm just running this. See, the operators are standing under the top position. Okay, now these two operators are taking these parts together. Okay, now what we want to have is how we can have a shared operators. Okay, here comes the operator, here comes the operator. Tell me how can I make these operators turn. Okay, so this is your assignment. I hope you are going to do that. Now what we are going to do is we are going to ask these two operators to pick up a single object. No more, what I can say, no more. I'll just make this first available. Okay, I want two operators to be making lifting that particular part together. Before I tell that, let me know in the comment section whether you are already aware of that. Are you aware about that? That two operators would be lifting a single part. Is it? Do you know that? Just look at that, guys. We are having almost 2000 plus subscribers, right? And for this live session, we are having only two people sincerely watching this, supporting this, and most probably how many? Three, four. It is really, very hard then to bring such interactive sessions, guys. Please share it with your friends, ask them to join it, you know and then it is going to be very difficult for us to bring such sessions. It takes a lot of efforts to bring this up, as well as we have almost 14 people viewed this live session, came and gone. Okay, so I'll just do this thing. I'll show you the sharing task, and then we will be wrapping up for this today's live session. Let me know in the comment section who is live now. I see that's concurrent viewers. Is it Boris or is it Amira? Come on. Okay, so we have 5 likes. Thank you very much. Okay, so now let us do this coordinated task. Task sequence example 1. Boris, great. Okay, so now here this is your first task sequence example. What it states is we're going to have this thing, and let's see what happens. Two different stuffs. So what we are going to ask is we are going to ask them together to pick up a single part. So you have to do that by going into your custom task sequence and here. So what you can see here is that this example shows the code required to create a coordinate tags that calls for two operators to transfer the same flow item. So you need to use this coordinated task sequence example 2 by clicking onto this queue, going into use transport to make that. Again, you need to come here, you need to check whether the center object is 1, and that has to be a dispatcher which is connected to the center port. Okay, and that is what is going to happen. It's a predefined modular code into the system. Okay, and here it goes, guys. These two operators are transferring a single part together, and then they are going to do that again. Okay, great. So Boris, let me know a last question from you. What you would like to see at the end of this live session? And let me check if that is possible. And then we will be closing our today's grand live session on LeanSimCorp. Okay, anything, let me know you want to check out. So here we have all the multiple things. So we are having this coordinator task taking place together. Okay, what's up? Thank you. Thanks a lot. Thanks a lot. Hmm. Thanks a lot, Boris. The person, the another concurrent viewer, can you also chat in? Guys, do share our channel with your, college friends, colleagues, teachers, near friends, your employees, the companies you will be working on, not only for Flexim, but for industrial engineering, industrial automation, engineering, and different stuffs. So, guys, the another concurrent viewer, did you saw this, which I did now? This is very important, and this is the bonus for you guys watching this live video. Changing the color of the conveyors. It is really tricky. It was quite fantastic. Now you just look at in a matter of section, but to find it that out in a complete Flexim environment, it's very, very difficult. So that is the bonus one for you. If you have any doubts, let me know in the comment section, and we will be closing this live session for today. So, guys, do not forget to visit our website LeanSimCorp.com for exciting topics, for training classes, for simulation support, and many, many different stuffs. And keep visiting our YouTube channel LeanSimCorp. So that's all for today. This is our live executor tutorial all about task executors. I hope you loved this and enjoy your next week. Let us meet in another grand live video. I don't know when it is going to happen, not yet scheduled, not yet planned, but if you wish so, let me know in the comment section. Also, let me know different topics you would like to cover onto that. So, if possible, I'll try my best to bring that during that live session. So, that's all for today, guys. Bye bye. Thank you. Love you all.